Hello, my name is Xiao. I will be going over topic 14, video C. Let's practice 4 questions. Let's start with number 1. First, write a balanced equation. To write the chemical formula of aluminum oxide, we can look at the oxidation states of aluminum and oxygen. Al has +3 and oxygen has -2. If you switch the oxidation numbers, aluminum oxide's chemical formula becomes Al2O3. So the balance equation is 4Al plus 3O2 yields 2Al2O3. In the question, it says that it has an excess of oxygen, which means oxygen is the excess reagent. So aluminum is the limiting reagent. Limiting reagent means that all of aluminum is reacted. So then we find out the moles of aluminum reacted. For every 1 mole of aluminum, there's 27 grams. Divide 6.5 grams of aluminum by 27 grams, and we get 0.241 moles of aluminum. From the balanced equation, we can see that there are 2 moles of aluminum oxide for every 4 moles of aluminum. So we multiply and you get 0.12 moles of aluminum oxide. And now we find out the grams of aluminum oxide that can be formed. So the molecular weight of aluminum oxide is 102 grams. We can multiply 0.12 moles of aluminum oxide, which we found before, and we multiply that by 102 grams. And we should get 12.2 grams of aluminum oxide that can be formed, and that's answer choice C. Now I'm going to explain question 2. So if it says an excess of bromine, that means bromine is the excess reagent. So aluminum is the limiting reagent. The limiting reagent means that all of aluminum is reacted. So first we find out the moles of aluminum that reacts. 1 mole of aluminum has 27 grams. So we divide 6.0 grams of aluminum by 27 grams of aluminum, and we get 0.22 moles of aluminum reacted. Then we find out the moles of aluminum bromide that can be formed. From our equation, we can find that there are 2 moles of aluminum bromide for every 2 moles of aluminum. So we multiply and we should get 0.22 moles of aluminum bromide. Now we're going to find the grams of aluminum bromide that can be formed. We should get a molecular weight of 266.7 grams. We multiply 0.22 moles of aluminum bromide, which we found in step 2, and multiply that by 266.7 grams. And we should get 58.67 grams of aluminum bromide, and the answer is choice B. Now I'm going to go over question 3. Unlike the other 2 questions, question 3 does not tell you which is the excess reactant, so we have to figure it out. So first, we find the original number of moles of aluminum. For 1 mole of aluminum, there's 27 grams, so we divide 22 grams of aluminum by 27 grams, and we should get 0.81 moles of aluminum. To decide whether aluminum or manganese 4 oxide is the limiting reagent, we can calculate the theoretical yield of aluminum oxide, which is the product. So if aluminum was a limiting reagent, we can find the moles of aluminum oxide that can be formed. According to the equation, there are 2 moles of aluminum oxide for every 4 moles of aluminum. So we multiply and we should get 0.405 moles of aluminum oxide. Now we find the original amount of moles of manganese 4 oxide. The molecular weight of manganese 4 oxide is 87 grams. So we divide 13 grams of manganese 4 oxide by 87 grams, and we should get 0.15 moles of manganese 4 oxide. And if manganese 4 oxide was the limiting reagent, we can find the moles of aluminum oxide that can be formed. There are 2 moles of aluminum oxide for every 3 moles of manganese 4 oxide. So we multiply and we should get 0.1 moles of aluminum oxide. we can see that 0.1 moles is less, which means that manganese 4 oxide is a limiting reagent because it cannot produce as much as 0.405 moles. Therefore, manganese 4 oxide is the limiting reagent. So with manganese 4 oxide as a limiting reagent, we can find the moles of aluminum reacted. For every 4 moles of aluminum, there are 3 moles of manganese 4 oxide according to the equation. So we multiply and we should get 0.2 moles of aluminum. The question is asking how much of the excess reactant remains, so how much aluminum remains. So we subtract the moles of aluminum reacted from the original moles of aluminum. So it's 0.81 moles of aluminum, which we calculated from step 1. And you subtract that from 0.2 moles of aluminum, and we should get 0.61 moles of aluminum. Now we can find the grams of aluminum that remain. We can multiply 0.61 moles of aluminum by 27 grams, and we should get 16.5 grams of aluminum that remain, and that is close to answer choice C, which is 17 grams. So here again the final answers for the 3 questions. Thank you for watching.